Okay, so yet another question on CAPM, and especially an exam-like question on CAPM. And we're going to look at betas, but not any sort of beta question, one that's going to relate on finding a specific weight of an asset within a portfolio. This is not something that you will always see on an exam, but it's definitely a curveball. And I want to give you exposure on today's session on how to do so effectively like a top marker in an intro to finance class, either for your graduate studies, either for your undergrad studies, or even, you'd be quite surprised, for your level 1 CFA. So let's go through this together. Now, please, please, I ask this every time, go get yourself a formula sheet, okay? Either on eastmanhelps.com or the one that you have yourself, all right? And have it ready on standby, because we're gonna use it to identify the formulas that we need to use here. So really, really darn important. That said, let's move on to the question and let's actually highlight stuff and kind of talk about things as we go. So Jake starts investing. Jake started investing and he wants his portfolio's beta to be equal to 1.28. That's pretty interesting. Jake wants his portfolio's beta to be equal to 1.28. All right. So already there, this is an amazing segue to figuring out which formula we need to use from a formula sheet. If we're talking about beta, okay, and especially if we're talking about the portfolio beta, you already know that we're going to deal with either one of two formulas, either the one related to the SML or either the one related to the portfolio beta. In this case, my hunch, wink, wink, I did the question. My hunch is telling me that we're going to use the portfolio betas formula. So let me write it at the top of the screen because that's something that I really would expect you to do when you're studying. When you're studying and you know that you need to use one specific formula, please write it down on the paper. And then we're going to try to figure out whether the inputs, the parameters within this formula can be found within our question. It's always a game of finding the missing variable. It's a puzzle. It's not as complicated, okay? It's really that easy. You do not need to solve for anything else. So this is the portfolio beta. And the portfolio beta is simply equal to the weighted sum of its individual betas. Now, I know for a lot of students, this actually means nothing to you. And that's why we're going to try to make this a little bit more simple and something that's actually actionable, right? Something that you could use yourself on a problem. So here's how we're going to simplify this formula and something that's actually kind of digestible. So the beta of a portfolio could be actually expressed as being simply, okay, here's an example. The weight of asset A times the beta of asset A plus the weight of asset B times the beta of asset B plus the weight of asset C times the beta of asset C plus 3 little points to kind of highlight continuity, essentially saying that we're going to continue doing this step forever. So then weight asset D, asset E, asset I can't do G, F, then G, and so on and so forth. I don't know how to count my out or do my alphabet, but the idea here is that this is a series and we're going to do this forever. And we could actually get all the way to the infinite, like infinity, and we could call that and we could coin that as being the nth asset. Okay, so we're going to add them up all the way to the nth asset, right? So the weight of the nth asset times the beta of the nth asset. And that's going to be the formula that we're going to use within this question. I'm so sorry that I look like a fool and I don't know how to do my own alphabet, but hey, listen, at least with finance, I got you. So the portfolio of Jake consists of the following, all right? And this is particular. It consists of $10,000 invested in Pepsico, and Pepsico has a beta of 0.57. So if you were to go here, we could call Pepsico, we're going to call it as asset A, all right? And I guess I should kind of maybe stick with the color I had before. We're going to call this as asset A, such that the beta of Pepsico, asset A, would be equal to 0.57. Then we would also look through the question and it says, hey, $50,000, right, is invested in Apple, and Apple has a beta of 1.17. Let's go ahead and say that Apple can be coined as being B, all right? And therefore, we would say that the beta, I guess I'll write it here, the beta of B is equal to 1.17. Okay, and I guess it's kind of dirty. I can put it somewhere else where it looks a little bit better. There you go. However, Lucas has another 12,500 to invest. So he has more money to invest. Good for Lucas. Or I mean, good for Jake. Oh my God. Why is it Lucas? No, it's Jake. My bad. However, Jake has another 12,500 to invest, and he hopes to divide the funds equally. Okay. He hopes to divide those funds equally between Tesla stock with a beta of 2.17 and the risk-free asset. Okay, so he wants to divide the funds, but yeah, we're gonna kind of remove the part equally because that was a typo in the question. So he hopes to divide the funds between Tesla stock with a beta of 2.17 and the risk-free asset. So we could call Tesla as being C. We could call the risk-free asset as being D. Right? I'm catching up. I'm able to do my alphabet now. So we know the beta of C of Tesla is equal to 2.17. And at this point, this should be clear. The beta of D, which is the risk-free asset, is equal to 0. The reason why this is awesome, before even like doing any further computations, just by reading the question and literally defining the parameters we have, we're able to go back to our formula at the top of our page screen paper, and we're able to literally just highlight the stuff we know. In this case, we know that the portfolio beta is 1.28. So we could highlight that. That's amazing news. We also know that the weight of asset A, in other words, the weight of Pepsico is equal to 0.57. So we know that. We also know that the weight of Apple, which is asset B, is of 1.17. We also know that the weight of asset C, well, that we don't know yet. And it's funny because if we continue the question, actually, a little bit. By the way, I'm so sorry that I highlighted the weight. I'm sorry. I'm just trying to say the beta of A and the beta of B. This is literally this is the 15th question I did today. So my brain's a little bit fried. I'm so sorry about that. I'm sorry if you're like, what the hell is going on? This guy's crazy. You got out the video. If you're still here, thank you. But I mean, the beta of A is 0.57 and the beta of B is 1.17. Sorry for highlighting the wrong thing. And we could continue with the beta of C. So sorry about that, which is 2.17. And in other words, if we were to kind of like maybe add this right here as being weight of D times beta of D, we would also have the beta of D because we know that the beta of the risk-free rate is 0, okay? The beta of D, not the weight, the beta of D, all right? So now it's a question of continuing to read the question to the very end and then also figuring out what's our mission and then kind of just solving for a missing variable. I guess as easy as that. In this case, our mission is as follows. How much should Jake invest in Tesla stock? But not only that, how much should Jake invest in Tesla stock to achieve a beta of 1.28? That's extremely important to understand. So already they're kind of telling you like, hey, out of all of the stocks here that we care about, we really want to know how much you need to invest in this particular stock, the weight of C, okay? That's kind of what we're trying to figure out. But by definition, because we don't know how much is going to be invested into C, we also don't know how much will be invested into D, right? Because it didn't give us any amounts, particularly for Tesla and for the risk-free rate. But we're going to talk about that in just a second. However, what's really awesome is that we can actually figure out how much is the weight of A, how much is the weight of B. It becomes a simple game of like computing the total value of our portfolio in terms of dollar figures. So part one, I guess we'll write it like this. Part one, and I guess I'll zoom in a little bit just for it to be slightly legible for you all and slightly like well written. So part one would be to find the weights. Find weight A and weight B. It's literally as easy as that. So the first step would be to find, well, what is the total value of the portfolio? Okay, and that's really easy. Now, if my memory doesn't fail me, we saw something like 12,500, right? So we have that, and 50K and 10K. So all that you got to do is you're going to do 50 plus 10 plus 12 and a half, right? Because we have 12,500, you have 10,000, and you have 50,000. So from there, you're going to be able to solve for the weight of A, and you'll be able to solve for the weight of B. Okay? In terms of the weight of A, Pepsico, you're simply going to do, and by the way, this number here is going to give you 72.5. If I could do some basic math in my head, 60, 72.5, hell yeah. So for the weight of A, it's going to be simply 10K divided by 72.5K. And for weight of B, we're going to have 50K divided by 72.5K. All right, so really as easy as that. I've never done this question before. It's my first time doing it. So I'm actually going to go ahead and solve this on my calculator. So we have a really interesting amount. It's actually one that could not really get simplified for some reason. And I guess my brain is really that fried, but it's pretty fun. I like doing these questions. So we're going to have the weight as being equal to 0.13793. You could also call this as simply being 13.7%. And then for our friend portfolio, I mean asset B, we're going to have, it's crazy, we're going to have 0.68. .65. So 68.965%. And we want to know, well, how do we have to invest the remainder of the portfolio, the remaining pieces of the portfolio, to achieve a beta of 1.28, even if possible at all, to be honest with you. So being the first time that I made the question, we're actually going to have to see if it actually holds and or works. So now we have the weight of A and we have the weight of B, and it's about solving for the missing variable, solving for how much Jake should invest in Tesla stock. So let me zoom in a little bit, and we're going to use that as a little segue to kind of making sense of what does it mean to have a investment in both an asset and the risk-free rate at the same time, and how you should go about this on an exam. So let me just write it up. So we're going to have part B. I don't know if I wrote part A for the other one, but we'll see. Part 1, and I went to part B. I am on literal crack. I'm not, but just it's a way of speaking to say that I'm tired. So part 2, part 2 is solving for the weight for Tesla. So I believe solve for weight of C. Okay. Now, once again, if we kind of just take a step back, we could actually highlight the formula that we used right here. And we're going to copy it to just display what we're going to need to do. All right. So this is interesting because we know what's the portfolio beta that we're seeking. Okay, that should be pretty clear by now. We know that we're seeking a portfolio beta of 1.28. That's what we're going for. And we know that our weight for A, if we take a little step to the left, we know that that's going to be equal to 0.13793 times the beta of A. If we go back, we know that the beta of A is 0.57. So we could write that right here, 0.57, right? And then we know that we've invested 0.68965 into Apple. And Apple has a beta of 1.17. Okay. And I guess this is going to kind of spill down a little bit. So we're going to say that we then need to find what is the weight of C, right? Which is going to be multiplied by 2.17. All right. And then by definition, we're also going to find the weight in the risk-free rate. The weight of D multiplied by 0. Okay. But what's awesome is that if you guys remember what we did for portfolio theory, if you remember what we did for previous questions, that when you know that there's only a specific like piece that is left in a portfolio, in this case, let's say 68 plus 31, we're gonna do 68 plus 14 type of thing. We know that we only have like 28% left in our portfolio to invest. So technically, you could really just simplify, I guess, this value here, okay? You could simplify this as being simply one of two things. 1 minus x, and this being x, or you could make it as being the weight of C is what we're really solving for. So whatever is left will be invested in the risk-free rate. And what's really awesome here is that because we know that we're going to invest at the risk-free rate, we know that the beta of the risk-free rate is 0, such that really effectively, whatever we have here doesn't matter. So we don't even need to consider that because we're for sure going to find whatever is going to be invested in the risk-free rate if we find what we invest in Tesla. So I hope that's clear. All right, let me say it one more time. Because we know that only a specific portion of our portfolio is left, and only that specific, whatever is left of whatever that specific amount, right? It represents what's left. Because we know that we're solving to see how we're going to divide what's left, we only need to figure out one portion of what's left. We only need to find a small portion of the total value that is just like left for us to invest. So by definition, if you find what we invested into Tesla, you will find what we'll need to invest in the risk-free rate and vice versa. And also, what's really interesting is that because the risk-free rate has a beta of 0, we literally don't even care about that portion of our calculation because it won't matter. All right. So now it becomes a question of just simply solving for x. And let's do that together. Solving for the weight of C. Well, let's go and do that. It's basic algebra. All you got to do is plug it in within, your calculator or do the algebra. I'm a lazy person, so I'm not a lazy person, but I'm just gonna, do it with the Symbol Lab calculator just to be time efficient. Once again, this is the first time that I've done this question. So if there's any errors, please let me know in the chat, and I'm more than happy to help you in that process. Okay, we're gonna have x. Okay, so I'm going to take a step back just to make sure that we have all the right pieces of information such that we solve this the right way. If we take a step back here, we know that we're looking for our portfolio beta to be equal to 1.28. That's exactly what you see on the screen. And we know that the weight of our money invested in stock A, in other words, Pepsico, is equal to 13.793%. And we know that the beta of Pepsi is 0.57. We know that we've also invested ourselves into Apple, right? 50K over 72.5K. That's going to represent 68.8965%. And we're going to multiply that by a beta of 1.17, which is also there. Then we're going to add the x times 2.17 because x will represent the weight that's going to be invested in Tesla, while 2.17 represents the beta of Tesla. So we do have that as well. Now, of course, because we know that by definition, if we find the weight invested into Tesla, we will literally find the weight invested in the risk-free rate. We don't really need to consider that as another variable. We can simply do 1 minus x. Furthermore, we know that the beta of the risk-free rate is equal to 0. And because it's equal to 0, something multiplied by 0 will still be 0. So we don't care about that portion of our formula. So now that we have all of this, we could plug that in. We could solve for x. I'm curious to see what it'll be. So that's super, super duper cool. The weight, okay, of C, so the weight that has to be invested into Tesla, is actually equal to 18.179%. Okay, such that if you really look at it, this question could also ask you like, hey, what are you going to invest in the risk-free rate? Because in this case, you'll notice I'm just going to do a quick proof to make sure that everything is okay on my side. So such that I didn't give you guys wrong numbers, but it should be fine. Yeah, so you get the right amount. But what's really interesting is that you notice that this still doesn't give you 100% of your money that's invested, okay? Because if you do, if you know that, for example, right, 12,500, and I guess we'll have to maybe spill to the, let's go a little bit at the bottom, because our question is not over yet. So we know that 18% of your total money has to be invested into Tesla. In other words, this means that the dollar value, okay, and I'm gonna maybe like do this here. Sorry about that, just gonna make it a little bit nicer. This means that a dollar value that has to be invested in Tesla would be equal to 18.179%, right? Times the total value of our portfolio. Okay, and that's going to give us a specific amount. So we can actually go ahead and do that. So we can go ahead and maybe just remove this. And this would mean that only $13,179.78 should be invested into. So that actually means that we invested more money than we actually have available. And that's really interesting. That means that $13,000 and 179.78 will have to be invested into Tesla. Now, this is strange. Now, of course, on an exam, that'd be fine, and you could just answer that. But they could be crazy. Like, they could be sick, and they could say, you know what? How much do you need to invest in Tesla? But also, how much would you need to invest in the risk-free rate? If you remember what we used to do for Chapter 8, we had this notion of short selling, okay? So let's do a little example here. Let's do two things just to give you more context. Notice how 13.793 plus 68 plus 965, I mean 0.965, sorry, gives you 82%. Okay, this gives you 82%. 0.758. Such that you would only have this much left to invest. Sorry, I'm doing this step by step. You would only have 17.242% to invest. Okay, you would only have this much to invest. So obviously this is strange. This should be strange to you because you could literally only invest this much to reach the total value of money you actually have. Jake is going above his budget. In fact, he's going above his budget by, in this case, if I go do the math again, we could 18.179 minus 17.242. Jake is going above his budget by 0.937%. This is so interesting. This means that Jake decided to borrow at the risk-free rate. Okay, decide to borrow at the risk-free rate. So this would be the proportion of money invested in the risk-free rate. Okay, so that's really interesting. So if you go above the total proportion of money needed here, which is 100%, that means that you're borrowing at the risk-free rate, especially in this example. So in order for Jake to be able to invest 18.18% of his money into Tesla, he would have to borrow almost 1% from the risk-free rate. So that's how you solve the question. It's really interesting. Now, of course, in this specific example, we only wanted to know, like, yo, what are you investing into Tesla? And that may really like raise some alarms for you if you kind of like keep track of the weights that you're actually allowed to allocate. And that's why this like additional piece of context really helps. Because now you know that, okay, well, I could go above 100% if and only if I'm able to invest in the risk-free rate. And I mean, I guess borrow in the risk-free rate. So have a negative position in the risk-free rates, which is shorting. this is an interesting question. It's really fun. I'm happy that we got through it. That said, I hope this helps. I hope this gives you context. And please don't hesitate to kind of like write some notes, write some like, yo, this was not good enough, or you gotta do this, you gotta do that. I'm more than happy to help out. I mean, I'm here to help out. That's the only reason why, you know, I do this. So go on eastmanhelps.com if you want more resources that's not static, things that will always be evolving and always giving you a different outlook on how to study as a business student, either for your grad studies, your undergrad, or even your CFA level 1. And listen, on the YouTube channel, there should be like 100 videos almost like by now, if you're past September. So I'm happy to give you more resources and just go through it. So yeah, hopefully this helped, and I'll see you in a little bit. Bye-bye.